we're going to be in topic 7, block 6. And we're going to multiply and divide rational numbers, apply properties of operations to operations with rational numbers, use positive and negative rational numbers to convert measures across measurement systems, and use rational numbers to solve multi-step real-world problems. So today, to get started, I got a couple of opening questions for you. So I basically want to have a quick discussion of measurement systems that you are used to using in the United States or anywhere else. So in the United States, our customary unit system includes feet, miles, ounces, and gallons. What other measurement systems are you familiar with? So what else do you use besides feet, miles, ounces, and gallons? Nobody knows. What's something other than feet that we use to measure? If I measured my finger, am I going to measure it in feet?
No, you're going to measure in inches.
Yeah, inches would work. All right, what else?
Kilometers?
Say that again. Kilometers, yeah. So other places use kilometers. Some of us would use that. That's a good one. So if you travel to another country, um, has anybody ever traveled to another country? Well, if you had, just like Emma said, you might be traveling kilometers per hour. So that was a good one. So what would you do if we needed to translate from one system to another? Like for example, if we needed to convert liters to gallons, what do you think we would have to do? What would we need to know? If we had 1 gallon of water, how would we figure out how many liters it was? Would we need to know how much a liter was?
Yes.
Yeah, if we knew how much a liter actually was, would we be able to convert it between gallons and liters?
Yeah.
Yeah, we'd be able to do that. Yeah, we'd definitely be able to do that. All right, so let's take a look. What we're going to do is we're going to look at page 8. And if you would, Chandler, I want you to read page 8 for us.
Mr. Martin,
Yes?
I can't see your screen.
Can everybody else see the screen?
No, because of my Wi-Fi problems.
All right, let's see what we got going on. So we're gonna read page 8. Chandler's gonna read it to us. Everybody should see it here in just a second. Can you see it, Chandler?
Yes, sir.
All right, go ahead.
Some members of the hiking club are planning a hiking trip in Canada later this year. When they look up information about Canada, they realize that all of the measures are reported in less familiar units. Here are some of the facts they uncovered. Montreal,
Quebec, yeah.
Quebec, Canada. Mean temperature in June 20 degrees Celsius. Mean temperature December -6. Highest elevation 33 meters. lowest elevation 6 meters.
Thank you. So if you look at that down there in the bottom, it says to interpret this information, the hikers will need to convert the measure into units for what? What's it say right there?
It says to interrupt this, to interpret this information, the hikers will need to convert the measures into unit use in the United States.
All right. So what do you think we need to do?
We need to convert the measures used into the United States.
All right, so let's see what we know. If it'll let us click it. I think my computer froze. Give it a second. It's thinking. There we go. Read that for us, Jamal.
In the United States, the customary units such as pounds, miles, and Fahrenheit are typically used in commercial activities. But science, medicine, government, and many industries use
Metric.
units.
Good.
Metric units. The United States, Liberia, and Myanmar are the only countries in the world that don't use the metric system in their day-to-day commerce. And Myanmar is the process of transforming in the metric system.
All right. So we got the mean temperature in June is 20 degrees Celsius. Mean temperature in December is -6. Highest elevation is 233 meters, and the lowest elevation is 6 meters. So let's look at page 9. And we're going to look at the first panel on this animation. And basically what I want us to do is we're going to take this slider and we're going to move it up and down the image and see how the relationship is modeled between feet and meters. So what do you notice about 1 feet? What is it in meters? What is 1 feet in meters?
0.3048.
Perfect. So let's see what 1 meter is in feet. Man, it's jumping. What if you can just type in there? Nope. I guess it won't let us do 1 feet. What if it'll do 2 feet? No. Let's see what 10 feet would be. You won't do 10 feet. What's the problem, guys?
You probably won't be able to put on the exact number.
It'll do 1 foot exactly.
You got anxiety on your.
Oh, well, we can kind of see what's happening.
This month I'm doing that quiz.
All right. I don't think it's open right now.
We had a quiz today.
No. Only people that needed to make up their word. So looking at this, what are you noticing? Like 16 feet is about how many meters?
4.89879.
So what is that about?
5.
Yeah,
5 meters.
so about 5 meters is a little over 16 feet, right?
Yes, sir.
So this says to help you determine how many feet are in 6 meters, how about we run this to 6? All right, so I'm not 100% at 6, but look how many feet are in 6 meters.
19.
Yeah, a little over 19, right?
Yes, sir.
Well, we do know that 1 foot is point what? Did y'all write it down?
I think you said 48.
1 foot is 0.3048, okay? Or 3,048 ten thousandths meters.
All I heard was 48.
So what we're going to do is we're going to take this information. If you have not written it down, I want you to write it down right now. 1 foot is equal to 0.3048 meters. We're in topic 7, block 6 in our workbook. All right, so let's take a look at panel 2. So it says, did you notice that there are 2 units raised, or 2 unit rates that you can use? We got 1 foot equals 0.3048 meters, and it also shows what 1 meter is equal to. What is 1 meter equal to?
3.28.
All right. So when we get that, how can we use these unit rates to help us determine the number of feet in 6 meters? What could we do with that? How could we figure out what 6 meters are since we know what 1 meter is? You can do it. Somebody tell me what to do. Y'all work together. You know 1 meter equals 3.2808 feet. So how could you figure out what 6 meters would be in feet?
Multiply.
That's right. What numbers would I be multiplying? Zamian's trying to help y'all out. Y'all need to be thinking. What numbers would you multiply?
The 3.2808 times 6.
Do y'all agree?
Yes.
I do. I think that's going to work out perfect. If we do 6 times 3.2808 feet, that'll tell us how many feet are in 6 meters. Perfect. So we know that we're looking at a proportional relationship here, showing that we have a meter is 3.2808 feet. So 2 meters would be double that. 3 meters would be triple that. 4 would be quadruple. 5 would be et cetera, et cetera, et cetera, and et cetera. All right. It's going to continuously go at the same rate. So what is question number 1 ask in our workbook?
Record some measurements in meters and feet.
All right, so for that, we should have 1 foot is equal to what?
0.3304.
And what else should we have? 1 meter is equal to what? So it looks like I'm gonna have to just start calling on people and knocking some points off if I need to. Haley, 1 meter is equal to what?
3.2808.
All right, that's what we should have for number 1. What's question number 2 say, Lainey?
How many feet are in 6 meters?
All right, so y'all need to work together right now to figure that out. Isamian and Jamal told us what to do. Who can restate what they said to do? To Chandra, what did they say to do? All right, so let's do that. So how many feet are in 6 meters?
19.6848.
All right. Well, let's write down how to get our answer and let's put that there for number 2.
Well, I got the same answer.
Yeah, that's the right answer. So what should we have written down for our answer? Go ahead, Christopher. Tell us what we should have. Wish I was at home with Christopher so I could get him not to look at what he's looking at.
He's
Right
just
now.
looking down.
Christopher! Come in. He's on another level. Chandler, what should we have for our answer? What would I write for number 2? To show my work and put my answer in, what should we have? Azami and Jamal to Chandra, they all said what to do. Now we know the answer. So how would I show that? What would I do? If you can help him out, help him out.
You would do 0.3048 times 6, and you get 19.6848.
Perfect. 3.2808 times 6 equals 19.6848 feet. All right, so let's take a look at our next pages.
This is when I got my points.
You're doing great. Read this for us, Deonti. Montreal.
The lowest elevation is 6 meters. The hiking club members want to know what the elevation is in feet. Play the animation to converse the measures of those in Canada and most of the world. The customary ones used in the United States. In the last panel, you learned that 3.288 feet is in every meter. How can you use the proportion to confirm the number in feet in 6 meters?
All right, so let's take a look. So they're using a proportional relationship to find this out. We know that 1 times 6 equals 6. So if we do 6 times 3.2808, that'll give us our answer. And that's exactly what we did to solve this. So it says, what are other proportions we could use? What's another proportion we could use? Instead of using 6 meters, what's another measurement we could use?
Like in what way you talking about?
Like a different number other than 6?
5.
Yeah. So this says the number of feet equals 3.2808 feet divided by meters times the number of meters. That is a lot. All right. So it says, how could you use equations to confirm the number of feet in 6 meters? So can somebody else write an equation that's easier than this? Mine would just be number of feet equals 3.2808 times x, and x would stand for what? The number.
Number of meters.
Good job. The number of meters. That's how I would do it. That'd be a lot easier. And that's what they just came up with after they simplified it. So this right here is what Jamal and me just talked about. So this will give you your number of feet equals x, which is the number of meters, times what 1 meter is equal to in feet. And that's basically what it's saying. Read that down there at the bottom for us, Laney.
If there are 3.2806 feet in every meter, then you can multiply the number of meters by 32908 to determine the number of feet.
All right. Samantha, would you read this for us, please?
The club members found that temperature in Montreal is June 20 degrees Celsius. To
Interpret.
this measurement, they need to convert to
Fahrenheit.
Use the slider to explore the relationship between Celsius and Fahrenheit. To explore some typical benchmarks, click the buttons on the right.
All right. So it wants us to record these measures. And it says, what do you notice? What is 23 degrees Celsius in Fahrenheit? So let's see. Boiling point of water. Let's see what that is. So what's the boiling point of water?
To 12
Yeah.
degrees Fahrenheit.
Or how much in Celsius?
100 degrees.
All right. Zamian, did you take care of what you needed to?
I can't take care of anything because my Wi-Fi is bad today.
I got you. All right. Well, I knew you'd try to color my name, and then it went off. So
Yeah, Mr. Mon, I'm trying to take that quiz, and so like I keep on clicking on it, then it let me get halfway into it, then I say my Wi-Fi connection is poor.
Uh-oh. Well, wait till Friday to take that quiz, and let's just do this right now.
Yes, sir.
Down all night.
Does anybody know the freezing point of water before we check it?
-50.
What degrees does it start snowing?
Around
It's
what,
0 degrees.
20?
32 degrees.
Somebody just said it.
32 degrees.
Yeah, 32 degrees is the freezing point of water. Now, it can snow a little bit warmer than that because it'll be colder up in the air compared to what it is down on the ground, but it's not going to stick unless it's 32 degrees or colder. So, like today, if it would have snowed as cold as it was this morning, it wouldn't have melted quick. Yesterday, it kind of melted fast, and that's because it got up to 46 degrees. All right, what's the normal human body temperature? Does anybody know? I'm pretty sure it's 98.7 degrees Fahrenheit. Let's see.
Where's Mark?
Yeah.
It's clearly still snowing weather because my snowman's still standing up.
No. So it says the normal human body temperature is 99 degrees Fahrenheit. That's because 98.7 is when it's rounded, it's going to be 99. My temperature is normally around 96 degrees, though. So I'm not normal, I guess. So we need to be.
It'll be cold in our classrooms.
Yeah, we need to record this down in our workbook if we're not doing it right now. What do you think the normal room temperature is?
90.
It's about 65 in my room right now. 90 is really hot. I would think somewhere around 71, 72 degrees is probably comfortable for most people. Let's see what they say. They said 68 degrees. That's what it is in my house at night. In the day, I bump it up 1 or 2 degrees. All right, so everybody should have those recorded. 68 is pretty cold. You need to have a jacket on most of the time, or a blanket. So what we've done on panel 5 is basically we have explored relationships between Celsius and Fahrenheit. So we should have recorded several measures, such as the room temperature, the human body temperature, the freezing point of water, and the boiling point of water. So how could we determine if this relationship's proportional? What would I need to do with those 4 measurements?
You said what?
What could I do with these 4 measurements of Fahrenheit to Celsius to determine if this is a proportional relationship? So, or like, in other words, an equivalent relationship.
Divide.
Yeah, we could just divide them. Let's do that. Let's see what happens. So we're going to need to write this down more than likely. Let's do 68 divided by 20. We get 3.4. I'm going to put that over here. All right, let's look at this one. So here we would do 99 divided by 37. Uh-oh. What do you notice?
It keep going on.
Yeah, but look at the difference. Are those the same? No. So is it a proportional relationship?
No.
No, it's not. So if we were to double the number of Celsius, would the number of degrees in Fahrenheit double?
Yeah. Most likely, yes.
So right here, we're at 0 degrees Celsius and it's 32 degrees Fahrenheit, right?
Yes,
So if that was the case, we would have to do 100 times what number?
212.
Mm-mm.
212.
Mm-mm.
4. -4. Oh, that ain't -4.
0 degrees was 32 degrees Fahrenheit. So 100 degrees Celsius, wouldn't it have to be up in the 300s?
Yes, sir.
So is that happening? No. So can this be proportional? No, it can't. The reason it can't is because it's not continuously being equivalent to each other. It's varying. It's changing. All right. Let's take a look at this. It says, did you notice that the relationship between Celsius and Fahrenheit is not proportional? Here are some formulas you can use to convert between the two systems. Use one of the formulas to convert 80 degrees Fahrenheit to degrees Celsius. So I want y'all to use these formulas right now. The formulas that we're talking about are this one or this one, and you're going to solve that problem right there. I want you to do that using those formulas. I'm going to give you about 2 minutes to see if you can figure it out on your own. And this is question number 4 in your workbook. All right, does anybody feel like they got the answer? Nobody attempted it? Did anybody attempt it? Did anybody get anywhere with this formula? What did we need to do for F? What did we need to put in for F?
80 degrees.
80, good. So we're solving for what?
Solving for C.
Good. So they put 80 in for F, just like Isaiah said. 80 minus 32 is 48. And then they did 48 times 5 nights. When they did 48 times 5 nights, what did they get?
27 degrees.
All right. So how do you do 48 times 5 nights? How do we do that?
think you have to multiply it.
Yeah, we do. We just take the whole number and multiply by the numerator, and we get 240, and then we divide it by 9. And so we got 26.6 that repeats, but we're rounding to the nearest whole number, and they got what?
27.
Correct. Wouldn't 26.6 round to 27?
Yes, sir.
All right. So what we're going to do is we're going to take page 10 and answer question 5 in our workbook. All right, so if you would, Miss Sarah, would you read this for us, please?
Yes, sir. Use what you learn about converting between measurement systems to complete the table.
And so it gives us the lowest temperature recorded is negative 45. We have to determine the metric measurement for that, which would be Celsius. All right. Then we're looking at the highest temperature recorded in Death Valley. They give us Celsius, but we need to convert it to Fahrenheit. Then we have the highest elevation. It's given to us in meters, so we need to convert it to what?
Celsius.
Not Celsius, but feet. Feet, because we're measuring it. And then the lowest elevation is given to us in feet, so we need to convert it to what? Meters. So we got meters, Celsius, Fahrenheit, and feet. So I'm going to give you about 2 minutes to see what you can come up with. Remember that 1 meter is equal to 3.2 what? 808 feet. Does that sound right? Y'all wrote it down on question number 2, I believe. Number 1 or number 2?
Yes, sir.
All right. And then they just gave us how to find Fahrenheit and Celsius. So they gave us what? It was back on this page, on page 9. So we got 5/9 times F minus 32 equals C to get Celsius, or we can do 9/5 times C plus 32 equals Fahrenheit. And we're going to use those to answer this. So I want to give you a couple minutes to try that on your own. Emma, take us through the first one. How would you convert 45 degrees Celsius, 45 degrees Fahrenheit to Celsius? What would you need to do at negative 45?
So first, I did negative 45 plus 32, and I got 77, and then I multiplied that by 5, and then I divided that by 9, and then rounded to 43.
All right, so would it be negative or positive?
Positive.
All right, let's take a look at it. So I got negative 45. I'm going to do what you said. So I got negative 45 minus 32. So I got negative 77. All right, now I'm going to multiply it by 5. And then I need to divide it by 9. So I got a negative.
Yeah.
So does that's right, huh? Let's check it. Negative 43? Yeah, that looks good. You did a great job. All right, Haley, I want you to tell us how to go from Celsius to Fahrenheit.
She just left.
What? Chandra, show us how to go from Celsius to Fahrenheit. What do we do? All right, well, let's just make it happen. Take a look at this. It says 57 degrees Celsius. So what goes in for C?
27.
That 57. Now, do I do multiplication or addition first? Think about PEMDAS, the order of operations.
Multiply.
Correct. So I'm going to take 57 and multiply by my numerator, which is 9. And now I need to divide it by the what? What's the part of the fraction on the bottom?
Denominator.
Correct. So I did that divided by 5, and I got 102.6, which would round to what? What would be the nearest whole number? Would it be 102 or 103?
103.
All right, and then I need to add it to what?
32.
So we're going to get 130 what?
5.
All right, let's check it. Is that right? Should have got a yes. Good job.
Yes, sir.
All right, now we're on to the easy stuff. We're taking meters to feet. So what would I do with my meters to figure out my feet? What do you think, Isaiah? You and Jamal told us earlier what to do.
Multiply.
Yeah. What am I multiplying?
Multiplying.
What are my meters?
Multiplying 4. I can't even speak because my Wi-Fi is going out. 4,421
Times.
times 3,280.
All right, so we got times. Oops, I messed up. 4,421 times 3.2808. So we get 14,504.4. What's that going to round to in the nearest feet? Would it be 504 or 505? Everybody can speak up. Come on.
5, 4.
Yes, 14,504. Perfect. All right, then we got one left. Lowest elevation's negative 282 feet. Now we got to convert it to meters. So 1 foot, what was it? What was it equal to?
0.040.
All right, so what do I need to do with my feet and this number right here?
Multiply.
Yeah. So we got negative 282. Am I going to get a negative or positive answer?
Negative.
Yes.
Negative.
And what do we get?
Negative 86 feet.
All right. Do y'all agree or disagree?
Agree.
Perfect. Perfect job. So that was question 5 in our workbook. Now all we have left is question 6 on pages 11 through 12. So we're going to knock that out very quickly. All right, Haley, read this for us.
Converting international recipes can be a challenge. Not only do they typically use metric units, but non-liquid ingredients, such as sugar and flour, are often measured in grams. A measure of weight. Notice that a cup of sugar and a cup of flour have different weights. Can you use the baking conversion to translate the recipe into U.S. customary units? Drag the tiles to solve the puzzle. Note that you may need to round to the nearest 1/4 unit.
All right, so to be able to do this, it says 1 cup of flour is 120 grams. All right, it says 1 cup of cornmeal is 160. So what's this going to be? 1 what? What did we just say?
Cup.
Yep. All right, so it says 50 grams of sugar would be how many cups? Well, 1 cup of sugar is 200 grams. So 50 is how much less than 200? That would be like dividing by what number?
4.
Correct. So if I do 1 cup of sugar divided by 4, how many cups would that be?
1/4.
Good. So the next one says 3 milliliters of salt is equivalent to 3/5 something. So let's see. Salt, salt, salt. I don't see salt. Do y'all see salt?
No, I don't see it.
Oh, there's milliliters is equal to 1 cup. 240 milliliters is equal to 1 cup. So what could we do? What's 240 divided by 3? Isn't it 8? Yep, 80. All right, so if we do 1 divided by 80, what do we get? I don't know, that's going to be weird. 0.0125. 3 divided by 6 is 0.6. Oh, look at this. It says 5 milliliters is 1 teaspoon. So what would we need to do with the 3 milliliters of salt? That'd be 3/5 of a what?
Teaspoon?
Yes, because if this is 5 milliliters and it becomes 3 milliliters, then that 1 teaspoon would be 1 times the 3/5. Let's check it. Yep, everything's looking good so far. So now we got 60 milliliters of vegetable oil equals how many cups? What do I need to do with this? What's 240 in that 60 milliliters? What is 240 being divided by to become 60?
3.
6 times what is 24?
4.
Yeah, 4. So we need to do 1 divided by what?
4.
Yeah. All right, and the last one says bake at 220 for 20 to 25 minutes. So that's Celsius. So we need to convert Celsius to Fahrenheit. So we did that earlier by doing 9/5 times Celsius plus 32. So we got to do 220 times what number? What's the numerator of 9/5?
9.
And then I need to divide it by what number?
5.
Then I need to add my 32 degrees. So what do we get?
428 degrees.
Let's see if that's on there. Is that on there?
Yes.
Yes.
All right. We got it all knocked out. Make sure you have that written down for number 6 in your workbook. Anybody have any questions? Yes or no? All right, we're going to wrap up our exploring here on number 12. Jemiah, will you read this for us?
Yes, sir. You are beginning to see how rotational numbers, including negative fractions and decimals, can be used to solve problems in daily life. You have used rational numbers to solve problems involving distance above and below sea level.
All right, then it says to convert measurements. And it also says in the next exploring, you will investigate other situations in which your skills with rational numbers will help you solve problems. So in closing to today's lesson, what are some U.S. customary and metric units for length? What do we do for the U.S. and what do we do for the metric?
We did feet and meters.
Feet and meters. All right. What do we do for weight or mass? What do we do for weight? Here we measure in,
Pounds.
all right, pounds or ounces. And it said they measure in what? Started with a G. Grams. All right. Now, for water, we're still using ounces, right? For fluid, but they used, or cups or gallons, but they used what? Liters or milliliters. That's right. Good job. All right. Today, we are going to have just a few questions in more practice, and that is pages 19 through 22. And I would also like you to try to complete question 7, A through G in your workbook. I'm going to go ahead and set up your more practice questions now, and I will see y'all tomorrow, okay?